Hey guys, today in Fusion 360 we're going to talk about the datums for the X, Y, and Z axis, as well as the jig that I made so that I can bore these holes spaced evenly. Now in the previous video we discussed the model, and more specifically the way that we're going to mount the linear rails. We're going to be using these precision ground bars to use as our artificial datum here. That way we don't have to machine into our column and our base and destroy any of the castings. So let's take a look at how we're going to make a jig so that we can bore these holes. Basically what I've just done is machined a couple of soft jaws. These are just aluminum soft jaws for my 4-inch vise. I have then put a rabbet or a shelf 1/8 of an inch by 1/8 of an inch, and this will allow the Z and the X datum to just kind of be able to be clamped together like so into the soft jaws. Well, that's great, but we need to be able to index these holes because the datums are 27 inches long. So the way I decided to do that was to bore a couple of holes here in my back fixed soft jaw, and then I just made this aluminum jig here. So we've got a couple holes bored in here, and then we're going to use some M5 by 15 socket head cap screws to mount that. And then we've just put a pin here. This is a 4.2 millimeter diameter pin, which is the diameter of the hole here that we're going to be drilling, machining into the datums. And so what happens is we'll index the edge of the datum on this line I've scribed here for the Z-axis. That is the distance between this edge and the first hole. They all vary between the different datums. We have our X and our Y datums. So the starting point's a little different, so I just scribed a line onto the jig. So what will happen is we'll bore our first two holes here. We'll clamp it up like so. We'll machine these two holes and countersinks. We'll then unclamp it, pick it up, and we'll put this hole over our pin. Or actually this hole, I'm sorry, over our pin. And when we do that, then we'll just move down to the next two holes. Take this hole, put it on our pin, and we're going to do 2 holes per cycle. This was just the simplest way for me to do it. That way I could use the same setup for the Z-axis, the X-axis, and the Y-axis. Now the Y-axis, of course, it works just fine. It's just the hole's going to be off-center, which is great. We'll put this edge towards the rail, and that'll help hold that down. And then that way I can get away with using the same jig for all 3 datums. Doesn't really matter if the hole's in the center or not. We're just trying to secure this to the base. So that's what I came up with for our datum jig. Now one thing I ran into while trying to cam out these holes and countersinks, Fusion 360 does not like to have the countersink already drawn when you're doing your cam. And I'm not quite sure the best route to go about doing the countersink hole. This is what I came up with, which is about 10 different quick operations. And I know you think, man, you must be crazy. Why are you doing so many operations for just a little countersink? However, I didn't want to go down to the full depth and hog all this material out. This is steel, so I'm trying to just take a little bit at with each operation. I don't understand why Fusion 360, and I couldn't figure out a way to do this, but with the boring operation, you can see we can just kind of spiral mill the hole. Well, it would be great if we could just spiral mill the chamfer. Then I could just get away with doing it with one operation. We could sort of just spiral down to the correct depth, do one more circle just to clean the edge up, and be done with it. However, the cam operation and parameters do not have, or at least I couldn't figure out a way to make it spiral mill. It does have a ramp speed here when you're selecting the tool. On the geometry, that's another thing. If it's a countersink, then it has this big old diameter here, and this diameter is, you know, halfway down the thickness of the stock. So you have to not draw the countersink in order to get this diameter up top here. That was another thing that I kind of had to mess around with. On the passes, the only thing you can really mess with is the chamfer width, which is the amount of the tool that's going to be used, and then the offset here, which I'm using for the height. And you have to kind of play around with these numbers in order to get the correct chamfer that you need. But I couldn't see anything that would allow you to kind of ramp down in there. Maybe it's just my not understanding or something, but this is what I've got. I just go down. Well, let me show you the stock here. I just go down, and then I'm going to chamfer just a little bit with one pass, and then progressively, we'll just do the whole thing here. I'm going to progressively go down. I'm going to bore the hole. Actually, we're boring two holes, both of them here with this operation. And then, well, I went too fast there, but with each operation, you can see we will do a little bit more, a little bit more, a little bit more, and we'll do this final pass one additional time just to make sure it's clean, and then we'll move over to the next hole. We'll do it a little more, a little more, a little more, and one additional pass just to clean it up. That's how I plan to machine this out. It's really not ideal. However, I couldn't figure out a way to ramp this down. I thought, well, maybe I could fool Fusion 360 into letting me just do another boring operation. However, if you do that, you can't select a chamfer mill. So you'd have to create a fake end mill and try to do it that way and figure that out. Maybe you could do it like that. So I'm going to just try this and see how it works out. But that is our datum jig, and hopefully it'll work out just fine. So let's go out to the mill and we'll machine out some of these datums. Hey guys, well, here I'm at the mill, and you can see how the jig is created here. I've just got a couple of soft jaws, and then I've just mounted a jig with the pin here, and I've marked the starting location. I actually engraved that for the X, Y, and Z, and then all the subsequent ops will be here and here. And these are, I made them 43 millimeters apart. So I took a scrap piece. This would be for my, this one's for my X. So I started off right here. Just lined that up, made the first operation. Then I take and put that second hole on my jig, clamp it up, and do the next two holes. Then just keep going down like so. Do the next two until I do the whole thing, which in this case the X is 27 inches long. I was having trouble with the countersink operation here. Let me put this back. I was having trouble with the chamfer operation. You can see I went too far there and there's like a burr. Then I tried it, made some adjustments, came back, and it was too shallow. This one was, the depth was okay, but it was too deep and it kind of made that burr. Don't want that. This one was too shallow. The head of the screw sticking up. It needs to be flush or below. Then I made some more adjustments and I got it below, but it's too far below. So I came back and finally I think I've got it just right, where it's just below the surface there. It's not sticking up and I'm not taking off more material than I need to. So now that I have it done, it's just a matter of running this operation for all the different dados. We have our Y dado, which is going to end up being about 1.25 inches. It's 1.25 inches now. It's going to end up being about 1 1/8 inches or 1 1/16 inches, somewhere in there. But I've made the jig so that I can clamp both sizes, and then the X and the Z are both 3/4 inch. So the hole will still be the same distance from this edge over, and it really doesn't matter for the X. It'll be in the center for the X and the Z, and it doesn't really matter for the Y. It'll just be about 3/8 over from the front edge. So in order to get started, I'm just going to line the end. Now these are already 18 inches, which is the correct length for the Y rails. So I don't have to cut them to length or anything. So I'll just line that up on my line, which is my starting point for the Y. Now bear in mind, these holes to mount these datums aren't critical, but I did want to get the spacing. I didn't want to just bore them by hand. So I made the jig and I can get them all spaced exactly the same, and it works out, makes it look nice. So alright, I've got the Y mounted in there. We'll go ahead and machine the first two holes. Alright, so the very first operation is a boring operation. We're going to bore a 4.2 millimeter hole, two of those, with a 1/8 inch 4-flute carbide end mill, and then we'll come back with a 1/4 inch chamfer mill and do the chamfer operations. Like I mentioned before, I'm doing about 4 or 5 operations to just ease down and chamfer each one of the holes. Okay, so here we go. Then we've got a 90-degree 1/4 inch 4-flute end mill. Alright, take a look at that. Turned out pretty good, and our screw fits just nice. I'll get it in the camera, Sam. Alright, so now we just lift and repeat. Put it down in there, clamp it up. Alright, now on to the next two. Eighth-inch end mill. Quarter-inch chamfer mill. Alright, we can see how this is going to go. Just keep moving on down the line. We'll just keep moving on down the line until we get the whole thing done. Alright, so let me finish this up. And well, okay, I finished boring all the holes and countersinking to mount the y-axis datums. I didn't want to bore you, so I went ahead and finished those up. And you can kind of see how they're going to mount on there now. Just screw down in there, and I'll put the mounting hole, since it's not in the center, it's going to be closer to the rail. It'll be more secure that way. I still need to machine about 1/8 of an inch off of here to move this over so that the rail sits on there all the way. But that'll be in the next step. I'll do that after I remove the vise from the mill. I'm going to have to do that to machine those, so I want to go ahead and do the datums for the z-axis as well as for the x-axis here. So I'm going to do that, and in the next video we'll start concentrating on getting the rails mounted and machining the saddles. Alright, thanks for watching, guys. If you have any suggestions or questions, please feel free to comment. Thumbs up if you like the video. Thanks for watching the video. Please subscribe if you have not, and most importantly, be safe.